closely at the screen. What you are witnessing is not a modern CNC machining demonstration. You are looking at a 900-year-old structural anomaly located in the heart of Karnataka, India. The Hoysaleswara temple, built in the 12th century, contains dozens of these massive, perfectly symmetrical stone pillars. Mainstream historians and archaeologists will look you dead in the eye and tell you these were carved by hand. They want you to believe that ancient artisans, using nothing more than primitive copper chisels, wooden mallets, and sheer willpower, achieved a level of geometric perfection that challenges today's industrial capabilities. But engineering does not care about historical narratives. Engineering only cares about physics. Let's break down the physical reality. These pillars are not made of soft sandstone or limestone. They are carved from solid chlorite schist and basalt, materials so incredibly dense and abrasive that they would blunt a standard 12th century metal tool in a matter of hours. Yet, as you visually scan the surface of these columns, you don't see the chaotic overlapping strike marks of a human hand. You don't see the asymmetrical errors of manual labor. Instead, you see something terrifying. You see absolute mathematical uniformity. The circumference is flawless. The circular grooves wrapping around the stone are perfectly parallel. To a mechanical engineer, this is not ancient art. This is a recognizable manufacturing signature. In the modern world, there is only one way to produce this specific shape. You take a raw block of material, mount it horizontally on a massive industrial lathe, and spin it at high rotational velocities against a fixed cutting tool. It is called multi-axis turning. But here is the problem that makes mainstream science sweat. Some of these pillars weigh up to 4 tons. To spin a 4-ton block of solid rock fast enough to cut continuous uniform grooves into it requires a massive amount of kinetic energy and an industrial power source. You cannot spin a 4-ton boulder with a hand crank. We are looking at a mechanical impossibility. If the precision of a single 4-ton pillar shatters the historical timeline, wait until you see what happens when that same precision is applied to an entire mountain. Welcome to the Ellora Caves, the Kailasa Temple. This is not a building, it is a monolithic excavation. Mainstream historians claim an army of laborers spent decades chipping away at a solid basalt cliff with hand tools. But the math contradicts the narrative. To achieve this, over 400,000 tons of rock had to be removed, top down, from the peak of the mountain straight down into the bedrock, with zero margin for error. Think about the engineering logic. When you carve top down, you cannot fix a mistake. One miscalculated strike at the top. And the load-bearing pillars of the lower chambers, which won't be excavated for another 10 years, are compromised. This requires a 3-dimensional spatial blueprint mapped directly into the rock, a concept we call CAD, computer-aided design. Ancient manual labor does not use CAD, it uses trial and error. Kailasa has no errors. But we already established this in file number 009. The true anomaly isn't just visual, it's acoustic. The lower chambers weren't just carved to hold weight, they were excavated with specific volumetric dimensions to act as cymatic frequency tuners. To tune a room out of solid bedrock, you don't chisel, you vaporize. You use high-energy subtractive technology to reach the exact resonant frequency. Hoysaleswara shows us they had the mechanical power. Kailasa shows us they had the spatial processes. We are looking at a localized industrial grid, a lost civilization that operated on kinetic rotation, geometric perfection, and acoustic resonance. The orthodox timeline is broken. The copper chisels are a myth. The anomalies are right in front of us, set in stone. But the rabbit hole goes deeper. If you think the acoustics of Kailasa are impossible, wait until we step inside the oldest rock-cut chambers on Earth. Optical mirrors made of solid granite, pitch-black resonance chambers. Next Monday, we open file number 024, the Barabar Caves. Trust logic, question history. Welcome to the AEON Files.